Algebra 1. Here we go on part 2 of explaining steps for rewriting equations. As we go through this, please make sure you're asking questions. I'm here to help. Here we go. In 7.1 here, we're deciding is 0 a solution to each equation. So essentially, if x equals 0 in each of these equations, decide for each one, is it a solution? Does it make it true? In our first equation, if x is 0, I do my parentheses first, so I end up with 4 times 2, and I get 8 equals 10. So no, that one doesn't work. 0 is not a solution in that one. In the second one, I plug in 0 for x, and as I simplify, I have to do the multiplication here first, so 8 times 0 is 0, and then over here, I have to do my adding first in parentheses, and as I simplify, I get 12 equals 12. So yes, 0 is a solution to that one. In the next one, I plug in 0 for x, and anything times 0 is 0. So both sides end up equaling 0. Yes, that one is a solution. This last equation has us taking 6 divided by 0. Dividing by 0 is like the biggest rule in math that you cannot break. You cannot divide by 0. We can talk about it in class, ask a question in class as to why we can't divide by 0, and we'll talk about it more. But for right now, just know that you cannot divide by 0. If you do, you get an answer of undefined. If you try it on a calculator, it will not do it. So in our last equation, no, 0 is not a solution because you cannot be dividing by 0. Okay, we're going to jump ahead to 7.3, and we're going to have Noah solving equations. In each case, he took steps that he thought were acceptable, but he ended up with statements that are clearly not true. So we have to figure out, did he use acceptable moves, or why do you think he ended up with a false equation? Here we go. In number 1, here's his original equation. The first step says that he applied the commutative property. If you remember that, that just means that you're moving things around. So he took his negative 3x and his positive 1, and he just flipped them right here. That is a legal move. You can do that. That's just fine. The next step says that he combined like terms. He had 4x and negative 3x. That would combine to just 1x. Remember, there's a 1 there. It's invisible. Next thing, it says that he subtracted x from both sides. He did that, and he ended up with 6 equals 1, which is clearly not true. He can subtract x from both sides. That is a legal move. So everything he did, all of his steps right here, were legal. He didn't make any mistakes. So why did he end up with this false statement? Well, it turns out if we look at this step right here, it's easiest to see that no matter what x is, the left side here is adding 6, the right side's only adding 1. And so the left side is always going to be bigger. No matter what x is, the left side is always going to be bigger. You cannot figure out a value for x that makes both sides true. And so we end up with this false statement right here because there is no solution. There is no value for x that's going to make this equation true. Now on to equation 2, we have our original equation. The first step says that he did the distributive property. So he took 2 times 5, that's where he got 10. He took 2 times x, that's where he got 2x. Then it says that he subtracted 10 from each side, and we can see that he did that correctly. He took 10 minus 10 here, and he took 9 minus 10 here, so that's where he got his negative 1 on the right-hand side. Then he added 1 to each side. You can do that. That's a legal move. He added 1 to each side, so now he's at 2x equals 3x. His next step says that he divided each side by x, and he divided each side by x to get this 2 equals 3, which is a false statement. So why did he end up with this false statement? Let's look back. His steps look good. The first few, distributive property is good, subtracting 10 from each side is good, adding 1 to each side is good, but dividing each side by x right here, we cannot do that. We can't divide by a variable because what if x is 0? If x is 0, that means we ended up dividing by 0, and that is not a legal move. So make note of this right here, that you cannot divide by a variable because it might be 0. And so what we should do, if he's at the point of 2x equals 3x, he should subtract 2x from both sides of the equation. So on the left, he would just end up with 0. On the right, he ends up with 1x. And here it turns out that, yeah, x does equal 0. If you plug x equals 0 back into your original equation, you would see that it would make the equation true. So first looking at what was done to each equation, and then is our equation that we end up with equivalent? So in other words, were these legal moves? So in A, to get from our first equation to our second equation, we divided both sides by 5. And yes, we can do that. That is a legal move. Our second equation would end up being an equivalent equation. In B, we added 3 on the left. That's why this negative 3 is now gone. And we subtracted 3 on the right. That's how we got from 5 to 2. So no, this one is not going to be an equivalent equation because you got to do the same thing to both sides of the equal sign. And in B, that did not happen. In C, we divided both sides by 5. So yes, you can do that. As long as you do it to the same thing to both sides, you're good. And in D, we divided both sides by x to get from the first equation to the second. No, you cannot do that. You cannot divide by the variable because what if it's 0? You cannot divide by 0. All right, guys, so there you go. That's lesson 7, really focusing on what were those legal moves and what are not legal moves. So we'll be reviewing more in class. Make sure you're asking questions. I'm here to help. Take care, guys. Nice job.